So now we're going to talk about the toolkit functions and whether they have inverses or they don't have inverses or what the situation is. Now, for functions, remember, we have to have it be a one-to-one function if it's going to have an inverse. If it isn't one-to-one, sometimes we can restrict functions so that they will be one-to-one. So if we find one that's not one-to-one and we can restrict it so it'll be one-to-one, then we're going to do that. So this is going to be a good chance for us to review the toolkit functions. So you remember for the constant function, it's just a horizontal line. Now to pass the one-to-one test, it has to pass the horizontal line test. Okay, this does not pass the horizontal line test. And we can't restrict it. If you think about it, all those points have the same output, right? So if you switched X and Y, all of them are going to have the same input, and we would want it to be one-to-one. You would just have one point that you could use. And you can't really have the inverse of a point. I mean, it's just going to be one point. It's not going to be it's not going to be a thing. Okay, so we're going to say there's no inverse here. You're not going to get that line or part of that line. Okay, so no inverse. It's not one-to-one. Okay. The next one, if we remember the identity function, the identity function goes through the origin and it's a line. And does that pass the horizontal line test? Yes, this is one-to-one. So it's one-to-one, therefore it has an inverse. Let's see. Okay. X squared. Well, that's our friend the parabola, the quadratic function, right? That does not pass the horizontal line test. It's not one-to-one. But we can restrict it. Now they usually restrict it. What they do is they kind of take out this part of the graph. So they say, all right, we can have f of x equals x squared. But if we want it to be one-to-one and we want to work with the inverse, then what we have to do is say x must be greater than or equal to 0. Okay? Now this brings up a question about why do we restrict it that way? Why do we take off the left part of the graph? Why don't we restrict it so that x is less than or equal to 0? You could restrict it that way. They don't usually. They usually use the positive values if you can. But you can restrict it the other way. Sometimes, every once in a while, we'll see a problem like that. Okay, so originally this quadratic function is not one-to-one. But over here, we restricted it. This is the restriction right here. We restricted the domain so that it will be one-to-one. Okay, now when you graph that function, you just have this part of the graph, and that is one-to-one. Okay, so that's what's happening there. All right, let's see. Now we have the cubic function. The cubic function looks like this. Kind of. And that's one-to-one. So it has an inverse, and that's great. So we just have to restrict the ones that aren't one-to-one. 1 over x. Okay, that's the reciprocal function. And how does that look? Well, it has a piece that goes kind of like this, and then another piece over here. Oops. It kind of looks like that. Those should look the same. They don't. But I just can't draw. I only took one drawing class. Okay. Anyway, does that pass the horizontal line test? If you draw a horizontal line any place, is it only going to hit one spot? And the answer is yes. This passes the horizontal line test. This is one-to-one. Now, I know sometimes when it's approaching that asymptote, it's hard to see that it's not a horizontal line, but it's actually getting closer and closer to the asymptote. So it's okay. It passes the horizontal line test, and therefore it's one-to-one. Okay, now the reciprocal square function. So what does that look like? And you can look these up on your previous notes with the Toolkit Functions. We've talked about them a bit. Okay, it doesn't look like that so much, but pretend like I draw well. Does that pass the horizontal line test? No, that does not pass. This is not one-to-one. So it's not one-to-one, so we want to kind of take off part of the graph. I would, again, get rid of probably this part over here. And so I'm going to restrict to say that if I have f of x equaling the reciprocal square function, then I'm going to say x has to be greater than 0. Now, why didn't I say greater than or equal to 0? Because it's not defined if x is 0. So my restriction is x is greater than 0. And again, you could say, well, I don't want to restrict that half. I want it to be the other half, you know, but usually they keep it positive. Keep that math positive. Okay. So we've got another one. We've got the cubed root function. And the cubed root function looks like this. And that passes the vertical or the horizontal line test, so it is one-to-one, so no problem there. And then the square root function, oops, I was trying to be all consistent here. The square root function looks like this. And that also satisfies the horizontal line test, so that is also one-to-one, so we don't have a problem there. And then our last one, we get a little more space here, the absolute value function, that looks like the V, kind of like that. And so you can see that is not one-to-one. So we'll have to bring in a restriction. And again, we're going to base that, we're at the base of the V there. We're going to restrict that so that it says f of x equals the absolute value function, but we're going to have a restriction on the domain. X has to be greater than or equal to 0. Okay, and then that would remove this part of the graph, and it would be one-to-one.